To train a smarter AI today, the industry relies heavily on a singular strategy, hoarding massive datasets and constantly throwing sheer brute computational force at them until the servers generate intense heat. But attempting to build intelligence purely through volume is like trying to build a more efficient car simply by bolting on a larger gas tank. The industry has hit a wall of diminishing returns. Injecting billions of new data points into these models now yields progressively weaker improvements in actual capability. These centralized monoliths operate on forced binary logic. When you demand an immediate answer from a system that lacks context, the resulting computational strain inevitably produces massive energy waste and data hallucinations. To fix this, we have to leave the centralized model behind and move toward distributed, localized networks. Enter the Aurora model. This is a neuro-symbolic fractal architecture explicitly designed to process, to crystallize it, and decentralize knowledge at the local level. True artificial intelligence does not emerge from sheer scale. It requires a complete structural redesign optimized for absolute informational efficiency. To understand how Aurora achieves that efficiency, we have to drop down from massive server farms to the microscopic level and look at its singular building block, the elemento. From the outside, an elemento operates as a single vector, but looking inside, it's a spatial container harboring three components interacting under one governing law. Instead of binary math, Aurora uses ternary logic, cycling through three specific operational states. If the relationship creates a contradiction, the system hits state 0, a cross state, and immediately begins reorganizing its internal configuration. If there are multiple possibilities, it registers state 2, an open state. The network demonstrates actual cognitive patience here, holding those possibilities in suspension and requesting context instead of forcing a fake answer. By structurally embracing uncertainty through this open state, Aurora stops guessing, eliminates forced errors, and establishes a genuinely analytical intelligence. The mechanics shift entirely when that operational window finds a coherent, unequivocal relationship and locks into state 1, the closed state. This animation shows a process called crystallization. The three vectors and their governing law synthesize into a brand new, unified unit known as a tensor superior. Standard language models have to recalculate statistical probabilities from scratch every time they operate. Aurora converts its active computation directly into a passive, hard-coded structure. The system calculates a truth exactly once. It locks that pattern into place, bypassing computation entirely by using a simple lookup mechanism. Instead of burning electricity to process the same logic over and over, the network builds a permanent, reusable foundation of knowledge, drastically reducing its long-term energy and computational costs. To see the true scale of this system, we have to pull back from that single tensor superior and look at the larger environment. Because this architecture is fractal, the crystallized tensor superior we just formed now acts as a basic single element in the next abstraction level above it. This macro architecture operates as a helical cycle without a central brain. Through downward causality, higher levels of the helix guide lower levels with necessary context. Simultaneously, through upward emergence, crystallized closures from the base travel up as new foundational values. In this reversible dynamic field, learning, inference, and reconstruction are no longer isolated algorithms. They are simply different directions of navigation. The Aurora model proves that true. Scalable intelligence does not come from forcing binary commands through a centralized monolith. It emerges organically through the collaborative resonance of a distributed fractal network.